Oh, okay. All right, so that OD sizing that we just did, that works really great. But the way we just did it was like for a weld where the seam weld, where the outside surface is completely flush, where you can walk the probe right over the top of the weld. What if you have a weld that has some weld crown, and you go to do that technique, bonk, you would hit the weld, you wouldn't be able to walk over it. So we have a way of dealing with that. The sizing isn't quite as good as if you could grind it flush and walk right over it, but you know, we can't always grind the weld flush. So we can deal with that. And so let's say we have a weld with an OD weld reinforcement. On a seam weld, and we have an OD crack that comes down to a certain depth. So we could take our probe and we can walk up to the flaw, and we can start to see that that creeper wave signal, that angled L wave signal, start to come up our screen, and then bang, we're going to hit that, and it's going to stop coming up. But we can watch that echo dynamic and compare that echo dynamic to the echo dynamics on the notched block, on our cal blocks, and use that to get a sizing estimate. So let's go ahead and try and do that on our notch blocks. All right, so I'm going to go ahead and set something up that's going to simulate a crack on a weld that's a 1/2 inch wide. So I got this little mag tape here. So this is going to block us from walking over the top of this 50 thousandths notch on our side drill hole block. And that tape is looks like about 450 thousandths wide. So it's about 1/4 inch where we're going to be blocked from walking over the top of it. So let's see how this is going to look. So we can see ourselves right here. This is our L wave signal. We should be recognizing that we know. Let me put it this way. For an OD crack, you'll normally know it's there because you can see it visually or see it with your mag, so you know it's there. So when you come and walk your probe up to the weld crown like this, you're going to recognize that as being the walk of that L wave going up against the OD flaw. So I'm going to simulate this obstruction. I have an obstruction now there, that weld ground, and I'm going to simulate that obstruction ultrasonically. And I want to simulate it by always having my signal stop at about, let's see, what depth is that? That's 183 thousandths on my depth screen. That's where it is. Okay, so I'm going to go ahead and I'm just going to use the notch block now, and let's start with let's see, 10, 30, 60, 90. Let's start with the 90. So I want to simulate this to be at about 130 thou. And okay, forgot to do something back here. Sorry about that. So we're gonna walk up to the flaw, and we're gonna make a note of where it is and how loud it is. So our actual flaw is at about 20% screen height. And where we do that is about, on our depth screen, 183 thousandths deep. So the number I want to remember is 20 thousandths. Alright, now let's come back to our block and compare that to our different notches on the block, and we'll start at the 90. And where I want to do this is I want to bring that so it's 183 thousandths deep, right around there. And that's way too loud. So that must be deeper than our actual crack was. Let's try the next one. Here's the 60. And I want to bring that to about 183 thousandths deep on the screen. Get some coupling down there. And that's a little bit louder than our flaw was. That's about 30% screen height, and our flaw was 20%. So this is probably a little deeper than our flaw was. All right, let's try the 30. Now where I want to walk this to is I want to walk this to about 183 thousandths deep on the screen. So right about there. And as far as how loud it is that's nowhere near 20% screen height. So it should be quite a bit deeper than this, but a little bit less deep than the 60 thous. So you could estimate it's about 50 thousandths deep, and that's what it actually was. And that technique also works very well. So the key thing to remember is you want to simulate the obstruction and figure out where to simulate the obstruction ultrasonically by how deep it is on the screen. And then compare the amplitudes of the notches to figure out what you think the notch of your crack was in the center of your weld, or wherever your obstruction is. All right, thanks a lot.